Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list published on November 11th, 2025, about 1 week ago. It turns UI to code into an interactive, multi-turn workflow and reaches state-of-the-art among open-source models, with UI Polish accuracy at 80% on UI Polish Real and 94% on UI Polish Synthetic, plus up to a 12% boost from 4 rounds of test time polishing. The paper is titled UI2Code N, a visual language model for test-time scalable interactive UI2Code generation. And as we'll see later, the implications for model training and real-world front-end automation are quite significant. Also, the authors shared a GitHub repo. You'll find a ready-to-run demo for web and command line, scripts to load pre-trained checkpoints and generate UI code, a quick start with dependencies and sample code, assets, and a short video, plus evaluation scripts and benchmarks for UI2Code and polishing. On Hugging Face, UI2Code N provides a 10 billion parameter visual coding model, BF16 safe tensors, quick transformers examples for UI screenshot to HTML generation, plus a clickable demo space. Alright, Figure 1 argues that interactivity makes UI2Code both higher fidelity and more reliable. The top row contrasts model outputs, and the polished variant visibly matches spacing, color, and layout more closely. The bottom left bars summarize head-to-head performance, where the unified generate, edit, and polish workflow leads among open-source options. The bottom right curve shows gains as interaction rounds increase, and test time scaling means repeating polish steps during inference to improve quality, for example using 4 rounds. Well, Figure 1 showed why interaction boosts fidelity. Figure 2 shows how the workflow actually operates end-to-end. The process links UI to code generation, UI polishing, and UI editing, which together mirror real developer iterations. UI polishing means refining the draft using the target image and the rendered output, and test time scaling means repeating these polished steps during inference to trade compute for quality. The left panel shows the reference screenshot. The bottom row illustrates editing, with a purple background and a 3-column card layout. So, Figure 2 showed the workflow. Table 1 compares models on UI2Code and UI polishing. The reinforcement learning variant leads open source with about 89 on design-to-code. It also reaches about 95 on Flame. On web-to-code, the score is about 93, which indicates robust generalization across layouts. For UI Polish Real, it records 80. On UI Polish Synthetic, it hits 94, so polishing remains a clear strength. Alright, Table 3 tests how reward design steers learning, which means the scoring signal in reinforcement learning guides how the model updates. This table shows that a round-robin comparator verifier yields the strongest polishing, reaching 93 on synthetic. On real pages, the same setup reaches 79. In the left subtable, accuracy rises as the verifier shifts from vanilla to comparator, and then to round-robin. In the right subtable, GLM 4.5 volts rewards beat Clip, with 75 on design-to-code. On Flame, the GLM 4.5 volt setting records 89, so human-aligned verifier signals provide clearer guidance than raw visual similarity. So the big takeaway is that UI2Code works best as an interactive loop that unifies, generate, edit, and polish, with test time scaling turning extra polish rounds into consistently higher fidelity pages. A second takeaway is that verifier-driven reinforcement learning, especially comparator-style rewards, makes the model robust on messy real sites. This points to practical front-end automation, where visual feedback becomes a first-class training and inference signal. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.